What does the anatomy of blood pressure look like? Well, today we're going to cover that in a little more detail, so stay tuned and don't go anywhere. Hey, this is Lance McGowan, the Tropical Smoothie Guy, and today we're going to cover the heart and what it looks like exactly from the inside out and how that affects your blood pressure, because blood pressure is a super important topic. It affects so many people. Actually, it affects everyone because everyone has blood pressure. It's either normal, it's either too low or too high, and so we really want to get to that normal state. And so I'm going to cover that in a little more detail and how it works in the next section.
Hey, it's the Tropical Smoothie Guy here, and we're going to learn about the anatomy of blood pressure. And so, understanding the anatomy of the heart and the large and small arteries of the cardiovascular system can help you understand why managing your blood pressure is important. And so, in the heart, the ventricles create systolic pressure when they contract to force blood out of the heart, and they create diastolic pressure when they relax to fill with blood. The arteries serve to move the blood through the system to the organs that need it. And this module shows how the artery structures work to move blood and how they can affect your health and blood pressure specifically. So, what is blood pressure? Well, blood pressure is the pressure exerted on the vessels that carry arterial or oxygenated blood throughout your body. It begins in the heart's ventricles and affects the arteries, the arterioles, and the capillaries. And the capillaries are really small. So, the understanding how the heart and arteries generate blood pressure will help you understand how high blood pressure or HBP can adversely affect your health. And so, the first image we're going to click on is the actual heart here. So when we click on that, you can see blood pressure in your arteries is generated by contraction and relaxation of muscles in your heart's ventricle walls. And so when we click one of these buttons, the systolic or diastolic pressure here, we'll see what happens. So we have systolic, so 120 mm Hg, so the right ventricle sends blood to the lungs to get oxygen, and then the left ventricle pumps oxygenated blood out to all the organs of the body. And then we look at diastolic pressure or diastole measures the pressure in the arteries between the heartbeats when the left ventricle relaxes and refills with blood. It is represented by the bottom number of a blood pressure reading, so it's 80 mmHg. So oxygenated blood returns from the lungs to the heart's chambers. Now, when we look at elastic arteries, we'll look at how elastic arteries are the largest arteries closest to the heart. And so the aorta and its largest branches right here. And then we also have the pulmonary trunk and the large pulmonary arteries right here. And so it's highlighted in that picture. So let's see the structure. So when we click on the structure, we can see now the elastic arteries. The tunica media is really interesting. There's so many layers, which is so fascinating with regards to arteries, but it's made mostly of elastic fibers. The tunica media stretches under systolic pressure and recoils during diastole, and this recoil helps push blood away from the heart and into the smaller arteries. So you have the tunica externa, the tunica media, which is right under that layer. The aorta is the actual artery, and then the tunica intima, and then the actual red there is the blood. So let's look at the animation now. So when we look at this animation here, we can see how it's working to pump blood. Really, really cool. That is so cool. Awesomeness. So let's look at the muscular arteries now. So the muscular arteries are small to medium in size and have a middle layer of smooth muscle, and we can click the buttons below to see how the muscle layer affects blood flow and blood pressure. So you have the inner elastic lamina right here, you have the outer elastic lamina right there, the tunica externa, tunica media, the tunica intima. There's so many layers. There's one, two, three, four. If you include the outer layer, it's 5 layers, and then you actually have the blood right there. So many layers to this, And the coronary arteries of the heart are muscular arteries. As you can see, yeah, they're very muscular. So you have a normal artery. The inside of the artery is where the blood flows. It's called the lumen, and when the lumen narrows, blood pressure increases. Let's look at vasodilation. Widens the inside of the artery as the smooth muscle layer in the artery wall stays in a more relaxed state, and vasodilation lowers blood pressure. And then let's look at vasoconstriction. When the smooth muscle layer contracts, the inside of the artery narrows. This is called vasoconstriction, and the blood pressure increases as the heart works harder to push blood through a narrower tube. So that's an important thing to keep in mind. You want blood flow to kind of go through a normal sized tube, not too wide and big, not too narrow. Now let's look at the arterioles, or the capillaries. The arterioles are smallest of all the arteries, eventually terminating into capillaries, which are really, really small. They're actually a seventh of the size of a hair that I don't have. But the middle layer of the arterioles consists of tiny rings of smooth muscle which act as sphincters. If these rings stay constricted, pressure backs up into the other arteries and the heart. So you have the small muscular artery here, and then you have the arteriole right there. The capillaries are what they kind of go into smaller, and the smooth muscle sphincters are there to kind of help constrict it, which is so cool. Body is so amazing.
As you can see, blood pressure is very important, and there's different conditions that can affect how your heart is able to regulate that. And the arteries are so interesting. I mean, I just want to say your body's amazing, and its ability to have so many layers to the actual arteries is so cool. And it's really so important to leverage what has been given to us. I mean, your body is so amazing, and being able for us to take care of that in a way that helps us keep those going and keep them healthy is very important. And I was looking on Facebook, and there a lot of people were like, "Hey, I have a family member or myself with a heart issue, or I had to get surgery or have some evasive procedure done," and they were attributing it to hereditary. And hereditary is a very interesting topic because some people think it's hereditary due to their genes, and some people think hereditary because of habits that have been passed down. And so I believe that addressing the root cause of the hereditary, and not just saying hereditary, but actually doing your research as to, hey, what is it about my family that I'm actually inheriting? Is it the bad habits, the eating habits, the lifestyle habits, the diet habits? Or is there actually specific genes that I'm predisposed to that make me more likely to have clogged arteries due to high cholesterol or other things like that? Or is it the diet and lifestyle that I'm having by myself? And so I believe the first thing to do before coming to any conclusion is do your research. And some of that's kind of hard to do unless you get a full gene mapping, but and that's really costly and takes a long time to process, like a couple months, and only a handful of people in the world have actually done it, but it's cool. The point is look at what's going on in your heart and do your research.